Hi, this is Stephen, and in this video we will discuss atrial size. So let's start with our apical four-chamber view. Got your left atrium, which empties via the mitral valve into the left ventricle. And then over here, the right ventricle and the right atrium. And how would we measure the size? Well, first let's make sure we are measuring it when the atria are at their largest. So that would be at the end of systole. Here's your QRST. So we're going to measure right there at the end of systole when the atria is at its largest. And for the right atrium, we are just going to trace this area here. And so that area should be less than or equal to 18 square centimeters. That would be a normal right atrial size. Well, what about for the left atrium? Well, for the left atrium, we can also measure the area here in the apical four-chamber. Now we have the benefit of a second view. Let me just shade in the left ventricle here. So if I rotate my probe 60 degrees, what will I get? I'll again see left atrium that is emptying into left ventricle. In the apical two-chamber view, and I can take the area of the atrium in this view as well. Just like we did when we were looking at left ventricular volumes for ejection fraction, I can take these two circles or these two ellipses, and I can basically, if I have the first one here, this from the apical four-chamber, and then I have second here from the apical two-chamber, I can sum a series of disks using the Simpson biplane method and get a volume. And so we want our left atrium volume index, we divide this by the body surface area, to be less than or equal to 34 ml per meter squared. So again, for right atrium, we look at just a size because we don't have an orthogonal view to give us a right atrial volume, and that should be less than 18 square centimeters. But for left atrium, because we have two almost orthogonal views, we can generate a volume, and that volume indexed by body surface area should be less than or equal to 34